Hello everybody, welcome to this episode on statistics, and today we are going to be talking about graphing numerical data. In this video we will be going through histograms, box plots, 5-number summary, and time charts. Let's get right into histograms. What is a histogram? What is skewness? What is the difference between a histogram and a bar graph? And how to identify a misleading and bad histogram? These are the questions that will be answered in this video. Let's take this as an example of a histogram. So an easy way to look and understand a histogram is by thinking of the x-axis like groups. The number of push-ups is the thing that they're measuring, the x-axis here. So the people who can do 20-30 push-ups are one group, and the y-axis is the number of individuals in the groups. So the people who can do 20 to 30 push-ups are one group, and 25 people are in that group. The people who can do 30 to 40 push-ups are in the second group, and around 17 people are in this group. Remember, all blocks should have the same width, and all these bars or blocks, whatever you like to call it, must be connected, because there is a reason behind this. Let's say group 1 is from 20 to 30, and group 2 is directly from 30 to 40. So it isn't from 31, but it's also from 30. So there isn't actually a number between 30 and 30. So there shouldn't be a space in between first and second block. Two things to consider or to note down when looking at a histogram is the shape of the data and the spread of the data. The spread, when I mean by the spread of the data, I mean by the variability. If the histogram is flat, that means it's very variable. The spread is huge because all the groups are spread out. All the groups are equally spread out, so the variability is the highest. But if the spread of the groups is one huge block in the middle, or on the mean, or on the average, that means it's not very spread out. That because everything is clustered around the average. An easy way to measure how variable or how spread the data is by calculating the standard deviation. If you want to know how to calculate that, check out our previous video. Now let's move on to the shape of the data. There are three different shapes of histograms. First being the right skewed histogram, second being the left skewed histogram, third being the symmetrical histogram. There are more types of histograms, but these are the three main ones that you should be knowing. Let's get into the right skewed histogram. One easy way to identify the right skewed histogram is by looking at the right side of the histogram right here, if it's pressed down or not. One thing to note down about right skewed histogram is that the mean is always greater than the median, because the mean is usually around the middle and the median is usually around the highest point. It isn't exactly there, but it's around there. And in this scenario, when the histogram is right skewed, the mean will always be greater than the median. Now let's look at a left skewed histogram. To identify a left skewed histogram, look at the left side of the histogram and see if it's pressed down or not. Similarly, if the data is skewed to the left, the mean is lesser than the median. Before, the mean was greater, now it's lesser, because the mean is again closer to the middle, to the center, but the median is closer to the top, and the bigger numbers are usually on the right side of the histogram. Now let's take a look at symmetrical histogram. You can identify a symmetrical histogram when it's pressed on both sides, or when it looks like a bell-shaped curve like this. And the mean and median are usually around each other, around the center. If it's exactly a bell-shaped curve or exactly symmetrical, then the mean and median are the same number. But most times it's not going to be exactly symmetrical, and it doesn't have to be exactly symmetrical to be considered a symmetrical histogram. Just keep that in mind. Now, what's the difference between a histogram and a bar graph? The first main difference we see is that there are gaps between the bars. Like I said before, there are gaps between bar graphs because they're talking about words here, so it doesn't matter. But in a histogram, 5 to 6, 6 to 7, there can be a gap. And the second thing, which I just said, is that there are numbers in a histogram but words in a bar graph, because histogram is usually used to graph numerical data, as from the title of this video, and bar graphs are usually used to graph categorical data. And if you want to learn more about graphing categorical data, check out our last video. Now let's take a look at some misleading or bad histograms. This histogram right here, because it magnifies every little difference. This difference right here. Let's take a look at these two blocks my cursor is pointing at. The difference between these two blocks is very little, and I feel like it doesn't even have to be shown because it doesn't give as much it doesn't give a lot of information. So the reason why it magnifies every single little difference is because the y-axis is the groups are very small. For example, let's talk about number of push-ups as from our previous example. It was 20 to 30. I think that's a good amount, 10 push-ups. But over here it's probably like every 2 push-ups. So the people can do 1 to 2 push-ups, 2 to 3 push-ups, 3 to 4, and it's unnecessary. We can just jump a bit more. But over here, on the contrary, it's the exact opposite. The groups are too big. We can't get any information from this histogram whatsoever. It's just 3 big blocks, and these two histograms are actually have the same data, but both of them are worse on their own way. So it's good to have perfectly a good number of the number that the y-axis jumps by must be a good amount. It shouldn't be too big like here or too small like here. Now let's look at this one. At first glance, there doesn't seem to be a big problem. The y-axis, the jumps are pretty good, and it's pretty neat. Not too much clustered. It's not too clustered. It's not too wide, or it does give enough information. That's what you might think, until you realize how much empty space there is up here. The difference between this block here, 25 to the individuals, talk about the individuals who can do 25 to 30 push-ups is around I would guess 32, 30, 33, and the people who can do 30 to 35 push-ups is actually looks like a much bigger number. It looks like I would say that's around 50. Like that's a bigger number. So the jump between these two is actually a very big number. People over here can probably only do like 35 push-ups, but people over here can do almost 50 push-ups. So this jump is very big actually if you think about it, but it doesn't feel very big because it's all of the data is smushed onto this surface over here. That is because we talked about earlier about how the jump in the y-axis has to be perfect, not too less, not too little. That also goes for the x-axis. In this situation, the x-axis jumps by a lot. It jumps by 30, and it goes all the way up to 120. And I think that's unnecessary. I think it's enough if it goes until 60, so that it shows the difference a bit more. This graph right here, this x-axis, the jumps, are undermining the difference between these two here. So take note of that. So yeah, making the points between the y-axis much bigger can make the difference feel smaller. Now let's talk about box plots. Before we get into box plots, let's take a quick breather here. Okay, in this part of the video, we're going to be talking about the 5-number summary, percentiles, which is what we have to know before we talk about the 5-number summary, and what are box plots, and how to identify misleading and bad box plots. So what are percentiles? The percentage of values that are small or smaller than the chosen value. So let's take this as an example. X is the 50th percentile. What does that mean? It means that 50% of the data is below it. Let's say, how do we calculate the percentile? Let's say that these are 5 different people. These are their weights. And we order them together. And also remember, the median is the 50th percentile. The median is always the 50th percentile. Okay, now let's get on to how to find the percentile of a number. So let's say you want to find the 75th percentile in this example. What is a 75th percentile? It's 75% multiplied by the sample size, which is denoted as n. The sample size is the number of individuals in that sample. So in this sample, there are 1, 2, 3, 4, 5. individuals here. So 75% multiplied by 5, that's 3.75. And 3.75, what we have to do now is we have to round it up. That makes it 4. So now just go to the fourth person numerically. You have to order them numerically and go to the fourth person from the least number. This is the least smallest number in the whole group. Let's count 4. That'll be this person right here. So how heavy is this guy? 70 kg. So 70 kg is the 75th percentile. That's how you calculate the percentile. And now we, in this example, the answer of 75% multiplied by the number of 5 is 3.75. You got a decimal number. What if it's a whole number? Let's say it's 4. What do we do now? So firstly, just do 4 plus 1, which is 5. Just add 1 to that number and go to the fourth person and go to the fifth person, which is just 1 add, and find the mean of both of these. So 70 kg plus 80 kg divided by 2 is 75 kg. So the 75th percentile is 75 kg. So what is the 5-number summary? Now that we know what the percentile is, the 5-number summary is the smallest number in the data set, the 25th percentile, the median, and the 75th percentile, and the largest number in the data set too. The 25th percentile is also known as the first quartile, and the 75th percentile is also known as the third quartile. Now let's get into box plots. In order to graph a box plot, we have to have the 5-number summary. We use the 5-number summary to graph the box plot. So, excuse me. So let's say that these are the numbers you got after calculating the percentile. The smallest number, 25th percentile, and so on. This is the 5-number summary that you've got. And how do you graph this box plot? And this is the corresponding box plot. So how did I graph that box plot? These are the numbers and this is the box plot. These horizontal lines represent the number. So this number is 12, this is 27, this is 33, this is 36, and this is 60. These horizontal lines represent the numbers in the 5-number summary. These lines here are called the whiskers. It's usually just to bind them all together. Let's look at this box right here. It's called the interquartile range. Interquartile range is basically third quartile minus the first quartile. So third quartile is 36 and the first quartile is 27. So 36 minus 27 is the interquartile range. So let's take a look at this box plot. You might be thinking, what is this dot over here? First of all, this is called a modified box plot, and this point over here is an outlier. This point over here shows that this is an outlier. An outlier is a number that's very big, too big, bigger than the data set. This point right here is an outlier. So how do you know if a number over here is an outlier or not? A data is considered to be an outlier if the number is smaller than the first quartile minus 1.5 times the interquartile range, or if the number is bigger than the third quartile plus 1.5 times the interquartile range. So what is the interquartile range? As discussed earlier, it's the third quartile minus the first quartile. So in our scenario, it's 36 minus 27, which is 9. So now let's replace this interquartile range with 9. Okay. Now that we replace the IQR with the 9, let's just replace the first quartile and the third quartile with the numbers over here, which you've already know, 27 and 36. And now let's just quickly solve these equations and we get these numbers. Going back to this page from before, let's put the numbers on the top left corner over here. If the number is smaller than 13.5, it's considered an outlier. If the number is bigger than 49.5, it's also considered an outlier. So 12 in this case is smaller than the outlier. It's smaller than 13.5. So you put a dot instead of going all the way to 12. And 60 over here is bigger than 49.5. So instead of going all the way to 60, you put a dot here. So the next question you have is, when does this whisker end? And it's actually very simple. these 5 numbers are not the only numbers in the whole data set. There are a lot of numbers in between them. Look for the smallest number that's bigger than 13.5 and the biggest number that's smaller than 49.5. That's where the whiskers end. So in our case, the biggest number that's smaller than 49.5 is, I would say, 46, somewhere around there. And the smallest number that's bigger than 13.5 is, in our case, around 15. So that's how you graph a modified box plot. And coming to our last chapter of the day, time charts. First, let's talk about what are time charts. Time charts are actually quite simple. They show the time in the bottom and the x-axis. It's basically like a linear graph. It's a bit similar to a linear graph. And reading a time chart is pretty simple. Just read it from the left to the right. Now let's talk about ways you might get misled by them. One way is by the y-axis, as discussed before. Be careful of how much the y-axis jumps by. Also be careful where the y-axis ends, because if it keeps going too high, it might undermine the difference. It might undermine the difference between these two. Over here, this is a good, perfect time chart. It's showing everything very neatly. The jump in the y-axis is not that big. And another thing to also worry about is jump in the x-axis. So these are all the things to be careful of a time chart. Thank you all very much for watching this video on statistics. I hope you found this video informative. If you have any questions, don't hesitate to put them down in the comments below. And if you like these type of videos on statistics, consider subscribing or check out my playlist on statistics. See you all next time.